All right, you guys are going to jump right into page 19 now. Trying to situate this camera in a way that's convenient. Once again, solving equations with fractions. We've already done this, but I'm going to go ahead and solve another one. If you can, you know what? Let's come over and solve this guy right here. All right, this is probably the hardest one out of the bunch. Again, probably the best thing to do is get rid of your denominators. I can see that 3 and 5 have a common multiple of 15, so I multiplied this side by 15, I multiplied this side by 15, and before I multiply, I reduce 3 and 15 to get 5, and 5 and 15 to get 3. Now I distribute through, which gives me 3x plus 3, distribute over here, 10x minus 10, and I'm gonna stop. You guys know how to solve. So isolate your x's from this point and move on. All right, just another example of how to set those up. These guys down here, same concepts. Remember, what you're doing is inverse operations. So whenever you see something that connected through addition, you do subtraction to undo it. Same, if it's subtraction, you do addition. If you see something connected through multiplication, you do division to undo it. If you see an exponent, right, if again a power would be connected, would be undone by root. So just as an example, let's go down and you know, let's do this guy right here. It's probably the hardest one on here. So I'm gonna circle what I'm solving for. I'm solving for b. And the first thing I notice is I got an a on the bottom. So we're gonna undo that division with multiplication, which gives me ay is equal to mx plus b. Now I need to get b by itself, right? So I have to get rid of m and x, which are connected to b by an addition sign. So I subtract mx from both sides. I subtract mx, and we're actually already done with this. I've got b, that's all that's left, and ay minus mx. If it's capital, try to keep it capital. That a was capital to begin with, meaning it probably represents a formula. A little unusual to have it set like this, but that's probably represent like a as an area. But try to keep lowercase, capital. Solving inequalities. This is a graph of an inequality. So you want to graph these. We notice that my highest exponent's a 1, so it's probably a linear equation, except we have these guys right here. So first thing I do is I'm going to solve for y like I would if I was going to graph a line. And I get y is less than negative x plus 3. And it really is just about graphing this line with a little bit going on in here. So my slope is negative 1. My y-intercept is 3. So I'm going to go to 3, and I'm going to go 1, 2, 3. Right? My slope's negative 1. That's down 1 over 1, down 1 over 1. And I'm just going to put a bunch of dots for now. And maybe that's what we'll keep. We'll keep a bunch of dots, but we'll see soon. I didn't do the best job. I got new glasses, and you think I'd be able to line it up, but I'm still getting used to these guys. All right, so that may be the graph, but it's an inequality, so there'll definitely be some shading involved. First thing I notice is that there is no equal. So whenever I'm graphing greater than or less than, I'm going to use a dotted line. Whenever I'm graphing greater than or equal to or less than or equal to, I'm going to use a solid line. This so happens to require a dotted line because there's no equal sign. So when you see a line under it, use a line. Next thing I notice is it says greater than. So whenever it says greater than, you can safely shade up. We can check it. I'm going to just mentally check it. 0 shouldn't be true because it's not shaded. So if I plug in 0, 0, plug in 0 for y, I get 0 is greater than 0 plus 3, which is 3. And since this point is not in the shaded area, it shouldn't be true, and that isn't true. You can get away with just shading up if it's greater than or equal to, and shading down with less than or equal to, and that'll work for you. Once again, page 19, and I'll talk to you guys soon.